Hello everyone, my name is Sushant, and in this video we are going to study the coordinate system. There are different types of coordinate system. In this video we are going to study the three coordinate systems. These are Cartesian coordinate system, second one is cylindrical coordinate system, and the last one is the spherical coordinate system. Now let's jump to the Cartesian coordinate system. We are all aware of the Cartesian coordinate system. It is a basic coordinate system. Its basic parameters are x, y, and z. It is also known as the rectangular coordinate system and right hand coordinate system because it follows the right hand rule. Now its range covers throughout the space, which are minus infinity to plus infinity. Let's see first this figure. This is the x axis, this is the y axis, and this is z axis. Now let's see, this is the point P. This point P having the coordinates x, y, and z. So its Cartesian coordinates are x, y, and z. Here if this x ranges from the minus infinity to plus infinity, y ranges from the minus infinity to plus infinity, and also z ranges from the minus infinity to plus infinity. Hence it covers the all the space. Now let's see the differential length. First of all, we see the figure. This figure we can see that here in this figure it's a box placed in the Cartesian coordinates. Now the dx, we have to find the differential length. If we move from this point P to S, we cover a small distance which is along the x-axis, so it is given by a dx. Similarly, we can find this for the find this dy and dz. When we cover the small distance from the S to R, we cover small distance along the y-axis, so it is given by a dy. And if we travel from the A to S, we cover the small distance which is given by a differential length as a dz. Now differential area. If you want to find the differential area, we have to consider a plane. If you consider a plane like SRBA, this plane, if you consider this plane, then in this plane the x is a constant because x is not changing, its x is the same, x value is the same. Now here only the y value y is changing and z is changing. Now if we travel from the A to B and B to R, we get the differential length as from A to B we get the differential length dy, and from B to R we get the differential length dz. If you want to find the area, we have to multiply this, you know that. So by multiplying we get the differential area as a dy and dz. Similarly, we can find this when the y is a constant. Like in this case the y is constant. For this case we can give the differential area as a dx dz. And when z is constant, for this case the z is a constant. For part of the box the z is constant, so for this case the differential area is a dx dy. Now let's see the differential volume. The differential volume is the multiplication of the differential length, so it's given by dx, dy, and dz. And the vector differential length is given by dx x bar plus dy ay bar plus dz az bar, where the ax, ay, and az are the unit vectors. These are the unit vectors. Sorry. Okay, these ax, ay, and az are the unit vectors. Now what is unit vectors? Unit vectors are the vector is can be given by a vector divided by the magnitude of vector. They are flowing in a direction from the smaller to the larger side. Hence it is the x bar is flow in this direction. Now az bar flows in this direction and ay bar flows in this direction. Now let's see the cylindrical coordinate system. Now when we place the z axis at the center of the cylinder, then we get Then let's see, this is the x-axis, this is y-axis, and this is the z-axis. Now z-axis is at the center of the cylinder, so from this center to the edge of the cylinder is the radius of the circle. It is given by the r. Okay, the r is the distance measured from the x-axis. Clear? Now next is this plane. If you consider this plane is the xy plane, which is along the x-axis, and the y-axis is the x. Okay, now consider this plane. Okay, this is the angle between this plane and the x-axis. It is given by the phi, the angle measured from the x-axis in a xy plane. Now z is the distance of this cylinder, so this distance is given by the z. Now the ranges of this, the r ranges from this 0 to infinity. It can goes up to the infinity. Now phi initially it is a 0 and goes up to the 360, and the z can go from the minus infinity to plus infinity. Now let's see the differential length. The differential length, first of all, see the video. In this video, the green area shows the radius of the circle, and the red area shows the xy plane, and the blue area shows the distance z. So as we can see, the differential length is given by a dr. When we travel a distance along the radius, it is given by a dr. And if we are along the xy plane, and it moves along at it having the radius r, and it is at an angle of phi from the x-axis, then its a differential length is given by r d phi, and the differential length of the this z is given by dz, because it travels from minus infinity to infinity. And if we take a small length on this, then it is given by a dz. Now a differential area is given by, when the r is constant, when the radius of the cylinder is a constant, then the differential area is given by r d phi dz. And when the phi is a constant, it's given by r dr dz. And when z is constant, it is given by dr r d phi. The differential value is given by dr r d phi dz. It's a product of the differential lengths. Now vector differential length is given by dr ar bar plus r d phi a phi bar plus dz az bar. Now let's see the spherical coordinate system. In a spherical coordinate system, first of all, to understand the spherical coordinate system, we will see the example of the Earth. Now in this figure, you can see that this is the x-axis, y-axis, and z-axis. This is placed in this origin is placed at the center of the Earth, and this is the latitude. This is the latitude of the Earth. This is the latitude of the Earth. These are the latitudes of the Earth, and these are the longitudes of the Earth, like this. These are the longitudes of the Earth. And another point is there, which is altitude. Altitude is the distance from the sea level to that point. If we consider these 3 coordinates, these are the difference for every point on the Earth. Let's see, for point P, this is the latitude and this is the longitude. Point P having the longitude this and longitude this and latitude this. Any other point on this Earth does not have the same latitude and longitude as a point P. Now let's see another figure. In this figure we can see that if you draw a perpendicular from point P and we connect this with the origin, the angle between this is given by phi, and the radius r, and a point connected to point P to the origin, and angle between the z-axis with this line is phi. Is a theta. So the coordinates of this point P is given by r, phi, theta. Now let's see differential length. The differential length is given by dr. For this radius it is a dr. For this angle it's r sin theta, and another is r sin theta d phi. The differential areas are given as, when the r is constant, the differential area is given by r square sin theta d phi. When the phi is constant, it is given as r sin theta dr d phi, and when z is constant, r dr d theta. These are the differential areas. The differential volume is given as dr r sin theta d phi. It is a multiplication. It is a product of the differential lengths. Now let's see the vector differential length. Vector differential length is given by dr ar bar plus r sin theta a theta bar plus r sin theta d phi a theta bar. Thank you for watching this video.